Okay, here I am writing the answer key for the practice test for rational and polynomial functions. Rational functions are simply ratios of polynomials, all right? So that's why they're related. So we're going to classify these according to those rules. What is this? This looks like a classic case of a rational function. Mark it with the scarlet letter R right there. What do we want to do? We want to say what the vertical asymptotes are. The VAs are at, let's see, you got to factor this thing super quickly. Be careful, it's a minus. That means we're subtracting to make 5. So that means it's a plus because the plus goes with the bigger number, which is 6 minus 1. So that means that's a 0 when it's minus 6. And that's a 0 when it's plus 1, okay? Be careful factoring. Put that into quad form if you have to. Horizontal asymptote is at Bobo needs to see. This is a Bobo. Bigger on the bottom. Bigger degree on the bottom means 0, okay? So, this guy here disqualifies it. That is a nothing, nada. And just make it clear that you can't have square roots. Can't have fraction exponents, which is what that is. This is a polynomial. It's written already in standard form. Wasn't that nice of me? We just want to find out what is the degree. The degree is the highest exponent there. You can just draw an arrow and write degree, or I'm going to write it here. It's 4. The lead coefficient, LC, is an invisible 1. Then this guy here looks like another classic rational function. Even if this does factor on the top, there's nothing to cancel to somehow make it be anything else. So I call that another rational function. Let's see. The 0 will be on the denominator, so we'll get a vertical asymptote only at x equals 0. And we will get a horizontal asymptote at, this is eats DC, so that's at 1 horizontal asymptote because these have the same coefficient when you consider the x squareds being equal. This guy here, that 3, divides into all of these. So this is a sneaky polynomial function disguised. I'm going to do 30. And then minus 6 is 24. 24 divided by 3 is 8. And then 12 divided by 3 is 4. And 3x squared divided by 3 is x squared. Don't need to do anything else other than say the degree is equal to 2. And the lead coefficient is equal to 1 again. Lots of boring ones. Sorry, there'll be more variety probably in the real thing. Going on with this. Multiply these guys, complex numbers, just a plus bi, imaginary part and a real part. I just need to FOIL these out. That is 16. I do the rainbow bits, and that's 24i. This is what, minus 10i. And when I combine those, I get plus 14i. This is the tricky bit. Just be careful. That's minus 15, but it's I squared. I squared cancels when I make it negative 1, so that becomes plus 16 and 15, 31 plus 14i. That is the correct answer. So just practice your foiling. This guy is just to make sure you don't only rely on your calculator. The idea here is to graph this rational function. Well, when is that equal to 0? That's equal to 0 when x is equal to negative a. So x cannot be equal to negative a. That is a vertical asymptote, just like up above. Also, it cannot be equal to 0 when that is b. So I go to b. Just make sure you're careful about reversing the signs. So Bot needs to see, well, this is x times x gives me x squared. So that's going to be x squared on the bottom with 3x on the top. Bigger on the bottom, it flattens out to 0. So you can do, I don't know, VA like that. And if you want to be fancy, you'd write x equals minus a and x equals b. And this one, horizontal asymptote equal is at when g of x equals 0. Or actually, yeah, that's good. That's good. So now what happens we need to graph this without a calculator. Here's our little smidge rule. All right, so we're really thinking when I'm a little bit above b, when I'm bigger than b, when I subtract b, it stays positive. So I'm just going to make 3 like cases here with fractions. Okay, I'm going to do this 3 times, actually 4 times. I'm slightly bigger, that's plus. A plus and a plus will be a plus. And then this is 3 times a plus, that's a plus. So this is plus infinity. We know it's going zooming up or zooming down. It's going to zoom up to infinity and then flatten out to 0. So you just want to sketch it like that. That is fine. Now when you're slightly less than b, when I have a number that's smaller than b and I take it away, this now is going to become minus. So a minus here makes this minus. A plus over minus is minus. So it's going to be here hugging this as it goes down. What happens when it gets close to 0, when x is 0? It is at the origin. And now what happens when a is a little bit bigger but negative than a? So if a is like 4, this would be negative 4. We're talking like 3.9. Well, negative 3.9 plus 4 is still positive, and that's negative because I've got a negative number and I'm subtracting b, the value of b. So now these would both be negative. Negative and negative. And then the top, when it's negative, would be negative. So now I've got 3 negatives. What does that give me? It gives me a negative over a positive because these two guys both are negative and will combine. So that's going to loop down and go like that. All right? In the home stretch here, we're just going to say, all right, well, what if this is negative 4? If I'm negative 4.1 right here, that's going to be negative. And this one would be negative. And this one would be negative. So that would be a negative over a positive. So that would be down. I want to just make sure I did that correctly. Let me just check this one out. If that is negative 4 and I'm at negative 3.9, then that would actually be a plus. That would be a plus and a minus and a minus. Oops, I made a mistake. I'm sorry. This is how I catch yourself. This is going to go up like that. Okay. One more time. Suppose this was negative 4, and I'm here at negative 3.9. Okay. That a value, that is plus a, so that's plus 4. And so negative 3.9 plus 4 would be positive. Yeah, so that would be a positive number and a negative and a negative. So that will go up, and it goes like this, like I said a minute ago down there. So room for all of us to make mistakes, but I caught it. Hopefully you'll catch your mistakes too. All right.